you will see in this slide, even if I take expectation of x bar equal to mu without the pinch of n tends to infinity, you will say what will happen to the variance, we will see that here. So now what about variance again? Variance is again a quantity that characterizes the probability distribution function. Remember, these are the quantities that characterize a random variable. The best one to do is probability distribution. I cannot do it, I cannot estimate the probability distribution because data availability is large, and therefore I am doing simple things like quantities like mean, variance, etc. Okay. So coming back, variance. Variance is a squared deviation from the mean. So you see how much variance is around the center point, the squared deviation. And of course you do not want to do squared deviation always, you want to keep the unit constant. So you do a square root of the deviation, that is nothing but the spread, which is also the standard deviation. And variance also has a different meaning. Okay, variance is also a representative of energy of the signal because it is a squared quantity. What is power? What is the formula for electrical power? You are all biomedical engineers. Energy by time, good. What is power in terms of square? Any quantities? I squared. A square. Power is a squared quantity. V into I squares. VIR, energy if you take VI, I squared R, right. So variance is representative of energy of the signal. Okay. The squared quantity is always a representative of energy of the signal. In signal processing, variance has a meaning, biomedical signal processing, you will see that variance has a typically a meaning of energy of the signal. Okay. And in order to keep the units constant, you take the standard deviation. Okay. And you do not take absolute, because why do not you do absolute? Absolute deviation, why do not you do? Absolute deviation, why will it go to negative? Absolute deviation, summation of absolute deviation, why do not I do that? Why do I do square deviation? Why not summation of absolute deviation? Many a times in the literature you want to minimize the energy of the signal, maximize the power delivered. Remember, in your op-amp or instrumentation circuits you will talk about maximum power delivery, right, impedance matching, etc., blah, blah, many things. So when you talk about minimizing or maximizing a quantity, you talk about differentiation, and absolute function is not differentiable at x equal to 0. So that is one of the reasons why we constantly avoid this absolute, at least in the earlier times. Now we use absolute many a times, but earlier we avoid absolute because it is not differentiable at x equal to 0. So that is the reason why we have square deviation and square root of the square deviation, clear. So this standard deviation, because it has the same units as that of the data, whereas variance will have squared units. Okay. Now what is variance of x bar? What is variance of x bar? What is variance of x bar? How do you derive it? That is, I am asking for the derivation. Right. Now variance is a squared quantity. So what is variance of x plus y? What is variance of x plus y? Huh? Derive na. But how derive it? The question is, when we start asking derivation, the basics you cannot mug it up. Okay. Do not mug up and then say what is covariance, etc., blah blah blah. What is variance of x plus y? How do I do this? Expectation of x plus y minus what? Mu x right? Yes or no? Agreed? So, this is quantity x, this is mu x or mu, so call this as z mu z, a minus b the whole squared, right. So, what is this going to be? Okay, clear. Now again this will become what? Sorry, minus. Okay, clear? Yes or no? These are the terms, right? Now then what do you do? Take expectation operator. So what do I have? This is nothing but expectation of, so individually take expectation, expectation is a linear operator. So this is nothing but expectation of x squared plus expectation of y squared plus 2 times what is expectation of x? Mu x, expectation of y is mu y plus expectation of a constant is a constant, so no mu x mu y squared plus 2 mu x mu y minus 2 mu x squared minus 2 mu x mu y minus 2 mu x mu y plus minus 2 mu y squared, correct, right, agreed. So what do I have? So I have expectation of x squared, okay, minus mu x squared, right, minus expectation of x squared. Simplify, I am simplifying. How do I simplify? Look at this, mu x squared minus 2 mu x squared, so gets cancelled, so you have mu x squared, okay, and similarly expectation of y squared minus mu y squared, and there are totally minus 4 mu x, 4 terms, right, minus 4 mu x mu y, and here how many? Plus 2, how many I have actually? Did I miss something? Plus 2 mu x mu y plus 2, there should be only one, okay. So I have plus 2, 2 plus 2 4, 4 minus 2 2, so plus 2 times mu x mu y is there, right. Then what is this? So what is variance? X minus mu the whole square equals to expectation of x square minus, right. What is variance formula? Expectation of x minus mu the whole square. If I expand it, what do I get? If I expand it, what do I get? Expectation of x squared plus mu squared minus expectation of x into mu. So what is this? 2 times. So what is this? Expectation of x squared minus mu squared, correct. This is 1 mu squared, this is 2 mu squared. So expectation of x squared minus mu squared is what? This is nothing but variance of x, this is nothing but variance of y, and this is plus 2 times this covariance, covariance is expectation of, covariance is going to be expectation of x minus mu x into y minus mu y, that is nothing but expectation of, I missed a term, that is where I am looking at expectation x y, yeah there should be, this term is expectation of x y, this term 2 times expectation of x y, that is what I missed, 2 times expectation of x y minus mu x into mu y, okay, and then we have what, x y minus mu x mu y, and then I have minus mu x mu y plus mu x mu y. So what do I have? Am I right? X y x mu y, which is mu x mu y, mu x into mu y, mu x into y, this is mu x mu y, and then minus into minus plus mu x mu y, these two gets cancelled. So what do I have essentially? Plus 2 times expectation of xy minus mu x mu y. This is nothing but covariance, the relationship between two random variables. We will not worry about this juncture. So what do I have? Variance of x plus y is what? Variance of x plus variance of y plus 2 times expectation of xy minus mu x into mu y. Now what is this? When will this term go to 0? When can this term go to 0? Just think about it. You have learnt it. I am not asking you anything unlearned. I am not even defining covariance here. I am just deriving basically. You all see this derivation, everything from simple formula. I have not used anything. Now here also I have this cross term, expectation of xy minus mu x mu y. So variance of x plus y is not equal to variance of x plus variance of y. You have another term, okay, which is 2 times expectation of xy minus mu x mu y. Everybody able to follow the derivation so far? Anything difficult? Simple a minus b the whole square formula, that is all I am doing. Now look at this term, the last term. So why am I deriving this? This means I cannot write this as variance of xi by n, I cannot write it as summation of variance of xi by n. You understand the problem? It is not a linear operator, variance is not a linear operator. But when will it become linear operator? When will it become linear operator? What is covariance? Forget the jargon. Which term has to go to 0? The third term has to go to 0. When will the third term go to 0? Look at the equation, do not give me jargons. Mu x mu y equals to expectation of xy. When will it become x? So that means expectation of xy should become what? Expectation of x into, when will it become? You have looked at this earlier. Expectation of xy should become expectation of x into expectation of y. Then this term will go to 0. When will it become? Huh? Somebody, yes, independent. Probability of A intersection B equals to probability of A into probability of B. I do not care about the happening of B, A does not care about B, B does not care about A. Here also we are saying expectation of xy equals to expectation of x into expectation of y, because x does not care about y. If expectation of xy equals to expectation of x into y, then this term goes to 0. So then variance becomes a linear operator. You understand? Then variance becomes a linear operator. So we have variance of x plus y equals to variance of x plus 2 times expectation of xy minus mu x into mu y. And remember, what is variance of x? Equals to expectation of x minus mu the whole square equals to expectation of x squared minus 2 mu plus mu squared minus 2 mu square. So this is nothing but expectation of x squared minus mu squared. Okay. So now this term, if it has to go to 0, x and y should be independent. Okay. That means expectation of xy equals to expectation of x into expectation of y. The same lines as probability of A intersection B equals to probability of A into. Got it? Clear? So far so good? Okay. Now coming back, so expectation of variance of x bar is nothing but variance of summation of xi by n. Now this can be interchanged under what assumption? Only when, that is, summation and variance operator can be interchanged only when, what assumption? Huh? But when will variance operation become linear? I showed you, na? Which are independent? What are independent? All xi's are. So what is the assumption you are making in x bar when you compute x bar? All samples are independent. Why do I make that assumption? If I make that assumption, what happens? What is variance of Ax? What is variance of Ax? Calculate, na? Huh? A times variance of x. Sure. Derive. Simple. Think. Try, na? Variance of Ax is what? A is a constant, right? A times x minus mu the whole square. Now tell me what is it? So this is what? A into x minus mu the whole square. So what is this? A is a constant, you take it outside, a square times expectation of x minus mu the whole square, this is a square times variance of x. Okay. So variance of Ax is a square times variance of, you do not need to mug up anything. If you understand, you can derive. I am deriving, I do not even remember all of this, no need to, you can just derive, right. So now going back, what is variance? Summation of variance of xi by is nothing but 1 over n square times summation variance of xi, right, I varying from 1 to n. Clear? Now what is this? 1 over n squared by, what is variance of xi? Sigma squared, we call it as sigma squared, that is your population variance. This is my population variance. Now how many times I have multiplied? N times. N and square get cancelled. So what do I have? Variance of x bar is sigma squared by n. So what happens as n tends to infinity? Variance of x bar tends to 0 and expectation of x bar we know is what? Mu. So as n tends to infinity, what will happen? X bar is mu, expectation of x bar is mu, variance of x bar is 0. So that means x bar becomes mu, x bar equals to mu as n is equal to infinity. That is why you use this formula. X bar converges to mu as n tends to infinity. Make sense everyone? Clear? That is what it is. Okay. So you should understand parallels. Why are we learning it? Without defining a population mean or a population variance, can I have come up with a formula for x bar? Like everybody will have a formula for x bar, right? I can come up with one, you can come up with one, nobody knows what is ground truth. So anybody can come up with mean and variance, but why particulars this one? Because you define the ground truth. Ground, only when you know probability, statistics even make sense, because they are highly interconnected. See the point? This way of looking at variance you would have never done, right? You would have been using variance for a long time. This is the reason why you are doing. Okay. So x bar converges to mu as n tends to infinity, because variance of x bar is what? Sigma squared by n. Okay.